to discuss about 4x1 mux. So we already discussed about 4x1 multiplexer design code and the true test bench code all in the previous video, but it is something look different according to the code. So explanation about the 4x1 multiplexer is same as before only, means for multiplexer is nothing but it has the multiple inputs and have the single output. So it is nothing but our multiplexer. So here we can observe there is a 4x1 multiplexer, there is a 4 inputs and 1 output. We already discussed about that. For 4x1 multiplexer we have 2 select lines. So 2 square is equal to 4. So for 8x1 multiplexer we have 2 power 3, that means so 8 inputs, that means 3 select lines. Later we can discuss about these 8x1 mux also, but until now we have discussed about 4x1 mux. In previous video already discussed about 2x1 mux. The select lines for this is 1. So 2 power 1 is nothing but 2. Like that we can you can consider that power as a set number of select lines. So here we are going to design the 4x1 mux by using this Verilog code. Here we can use if-else statements. So in previous video we are use case statement. So in previous video if you don't watch you can go through that. That is using case keyword. So here we can use if-else statements. So for that you know that Verilog code start with module and end with end module. So module and then we can follow by the module name. So you can take any module name here and there are the inputs and outputs here. So for here you can observe, so what are the inputs? They are the 4 number of inputs. So that's why you can represent 3:0. So it means, so index, it is indexing like that. So you can consider 3. So 0, 1, 2, 3, like that I will be in 4 parts. So like that I of 0, I of 1, I of 2, I of 3. Like that we have considered the 4 inputs. So how many select lines we observe here? They are the 2 select lines. Here in represent AB, but here I can represent as SCL variable. So 1:0 is nothing but 1 and 0 index. So nothing but 2 select lines. So output will be reg data type. So output is represented by out variable. So why you write reg means while you are going to use this out in the always block. So you should be that variable is should be reg data type. So that's why you can mention with reg. If you don't mention anything means it defaultly take while. So but always block is it not possible to done in the while. So while data type. So that's why you can must and should be represented with reg. So in test bench also for whatever the variables we are using in the initial block, we should be represented with reg data type. So like that here also we use assign the values for out variable. That's why you can use reg data type. So that's why don't forget to mention when you are using always block, you must represent the output with reg data type. So always is our always block and there is an at the rate and then there is a sensitivity list. So this bracket is nothing but our sensitivity list. So inside that we can represent with star. We already discussed what is the meaning of star. So star means what are the inputs. So I and the SCL variable. So what are the inputs? You can, if any change in one of the input, the block will going to be executed. So if you are write like this also, I of 0 comma I of 1 comma I of 2 comma, like that we can write everything is same as and so on, and then select lines, everything you can write is similar to the star. So whenever there is a multiple number of inputs, so it is very difficult to write every input. So that's why you can simply represent it by star. So star means it will be represent the whole inputs we are considered here. So next, once I can erase this all. So now you can observe here. So if else statement. So there how many set of you can get as output. So 4, they are the 4. So whenever the select lines like this, so 0 0 0 1 1 0 1 1. So these are our select lines. So whenever one set of select lines will going to be, then execute the one of the input as assigned to the output here. So then select line is 0 0, maybe D3 will be going to assign or D0 will going to assign. So if the select line is 0 1, then Y is going to be D1. So otherwise, sorry, D2 and otherwise D3. Like that, the changing in the select lines, we are going to assign the particular input to the output variable. So here we can see if select line is equal to, it means if the select line, what is the value of select line, it will be going to equal to 2 is nothing but what are the bits we are representing here. Here we can represent 2 bits, so that's why we can represent 2, and tick mark, it is a binary data type, so that's why I represent with B. So 0 0. So like that, if the select line is equal to 0 0, so our output will going to be the value of I of 0. So what is the value of I of 0? It is going to assign to the out. So else, so if this statement is not correct, so if the select line is not equal to, if the select line not equal to 0, and then if it is equal to, select line is equal to 1 means, so our out variable is going to assign the I of 1. So what is the value in I of 1? It is going to assign the out variable. So else, so this statement is also not equal. Then again else, if select line is equal to 2. So if equal to 2 means, then I of 2 value is going to assign to the out variable. So it is also false. So then select line is equal to 3. So defaultly there is only one case, so we can simply write else. So no need to write if statement again. So out is equal to I of 3. So what is the value in the I of 3? It is going to assign to the out variable. And end with this begin will stop with this end keyword, and then module is stop with end module. So like that we can complete the design code. Simply we can use if else statement. If it is select equals 0, so we can execute particular statement inside it. So if it is not true, then going to else statement. So if it is also not true, then going to other. Like that we can use if else statements. So if you have any doubts until now, you can comment it and slightly go to Testbench code. So in first video onwards, so first code onwards, so the syntax in the Testbench code is similar. So if the design code maybe changes according to our application, but the Testbench code is the syntax, whatever we are using inside this, nothing changed. So simply you can see there is a module and with end module. So followed by module name. We can observe any Testbench, so it is only the syntax. So module name. So why I can explain every Testbench means, so there is a input different input combinations. So input combinations may be different. So while you are seeing this, then if anyone know, then you can get a good idea about this. So I consider the beginners also, so that's why I can say every line and everything. So if you have any doubts on particular thing, you can simply comment on it. I will make an in detail about the Testbench code. So from so many videos I explain Testbench code, so no need to explain much about this. So you can watch previous video, then you can get a good idea about this Testbench code. But some of them I explain in this code, so don't worry about that. So if you want much detailed explanation about that, so you can comment it. I can complete detailed explanation will give on separate video. So until then, just go simply on about this. So what we can represent, so whatever the inputs will be in the reg data type, so output in the wide data type. So why only inputs will be reg, now not wide? If you have question means, so what are the variables? So I and select lines are used in the initial block. So what I say now, whatever the variables we are using in the always block and initial block, so it must should be the reg data type. So that's why I represent the input port. What are the variables we are used in this initial block? It must should be reg data type. So that's why I represent with reg data type. So output will be wide. So it is our design code module. So by this we can connect this design code to Testbench code. By using this only we can connect this design code and this Testbench code. So it is our design code module name. Design code module name. So Teju is our instance name, so we can use any instance name, no need to particular name. So mostly we can prefer DUT because design under test, it is a professionality and it means something, it is under design test. So it has a specific figure out when you are explaining the code, so it is reflecting on the code. So that's why I use DUT most on the professional manner. So why you use this means, every time I say, just we have to know. So it is not a rule, it is just for our understanding, and it is like simply reflecting on your design code, Testbench code in the proper manner. So that's why I use it. So no need to bother about this. So it is by port connection. So a port will be connected on two ways. So one is by name and another is by order. So here I can connect by order. So if you want the port connection explanation, you can go to other video. So other video means in previous video I give detailed explanation about port connections. So here I use order. So next there is the initial block. So initial block we represent the input combination, different input combinations we can take here. So what are the inputs here? I and the select lines are our inputs. So I is equal to, we can give different values. So no need to give some particular values like that. So we can give any values and then we can give select lines. So for our understanding, I did different select lines. So and corresponding I values. So why I use /5 means it already explained to you. So it is about delay. So /5 is nothing but our delay. So and then finally you use the finish keyword by using to end the code of the particular thing. So if you want to end this simulation process, so you want to use finish keyword by simply stop the code. So and begin is stopped by this end keyword. So these 4 lines are written to get the waveform in the EDA playground. So every time I say that EDA playground I use to for this particular code, so to getting waveform, so you can must represent these by 4 lines, so then only you can get waveforms. So and the module will be end with end module. So if you have any doubts, you can comment it. So if you are following the codes from starting to continuously, then you can understand in perfect way maybe. So if you have I can consider previous codes and then I explain according to that. If you don't watch them, so it is better to watch those all, then you can understand properly. If you directly want this particular code, if you have any doubts, anything, you can don't hesitate, ask in comment section. So comment section doors is always open for you. You can go to the output waveform. So let's go into the output waveform. So output waveform is represented like this. So you can see here, so this is our input I and then select line. So you can simply observe here the select line will be 0. So select line will be going to 0 means, so what is the value you are going to assign? So select line is equal to 0 means, so I of 0 value is going to assign it to out. So what is the I of 0 value? 1. So I of 0 is equal to 1, I of 1 is equal to 0, I of 2 is equal to 0, I of 3 is equal to 0. Here you can observe these values. So what we are going to assign to the out variable? So what is the value in the I of 0? It is going to assign. So you can observe here the output value is 1. So like that you can cross check whether you are what is the function of your code will be working properly or not. So select line is equal to 0. So when the select line is going to 0, then I of 0 value is going to assign to the out variable. So here it will be assigned. So your code is correct. Like that you can cross check. If you have any errors and you have any doubts, you can comment it. And thanks for watching. Until then, bye.